Welcome back to Wickerson Studios. Michael Wickerson here, and I am ready to continue, except I think yes, I'm ready to continue with the video 8, which is going to help teach people actually how to go right through and write the entire script. It's not going to be needed because I'm going to release hopefully early this week, I'm going to release this first few hundred lines of script and this first GH file here that will produce certain geometries and some data visualization in Rhino, which exists over here. It's not too exciting, but it's a simple script that I'm playing off of, comparable to what you'd see learning generative design. And I like the little script that's coming in. And I'm just showing that, like, I know normally you would just scale things with numbers because we're dealing with single lists, we're dealing with multiples, but scalars is a nice way to begin. I've got a little scalar here that you can actually just scale your file from your Numpy. That's assuming I didn't do what I just did. I'm going to crash out my Rhino in the process of doing that. What I want to do is make sure that I am running my script, save and F5. And if that's running, I shouldn't have any luck. I shouldn't have any trouble running this and getting the visuals. This should jump into some data and we should get something. There we go. You can get in and build your data. So it's kind of interesting to see that you're scaling this through Visual Studio Code. And that's not really apparent here, but it is if I took that model. It's tricky to work this when you have multiple screens. It's a little bit of pain in the butt. But you'll see down below, as I model and change this, your Numpy is changing and producing that array that's actually driving the data and scaling that data. And even though this is just baby steps to start, and you're asking yourself, why would I bother doing that when I could just do a multiplier, within the Grasshopper? Because you're multiplying, you're vectorizing. I think it's called vectorization. You're doing that to all the array points very quickly in what is actually, I've been told, C programming, because Numpy operates on that base level and moves incredibly fast. And without for loops, you're running 10 to 100 times faster than anything you've ever done. So that is why we're doing. So I'll push this down here. The data visuals are there, but we're going to continue with what's the next exercise. And of course, we made Numpy arrays, we made multidimensional arrays, or like dimensional arrays from multiple lists. What we're going to do, and I think we're in time for it, is we will now get into adding to 3D arrays, and that should write itself as we're going. So I'm going to take this off. I'm going to prepare for this. I don't need all this data over here double, even though it was just interesting to see. What I do want is basically, this might be how I want to start. Haven't quite decided yet. As I'm adding 2 arrays, I think this will suffice for it. I'm just going to gobble this up, copy and paste it. And we're not going to use that other visualization. We'll do another visualization study and mix it up a bit. But right here, we're going to go into Numpy array, and we're going to add, what exactly we're doing? Adding 2 3D arrays. So that's what we're going to do, or n-dimensional arrays. So we're going to add 2, and we'll just say n because we don't have to define what the dimension is. Yeah, and it's right there. Add 2. And I think what the first thing we're doing is, like, we're actually adding and we're just doubling. We're just going to add, which is similar to doubling. And it's not really exercise you have to do a n-dimensional array. You'll see what I'm doing. I'm not going to get into 2 different arrays right now. I'm just going to stick with one and just doubling it. And I'm going to show you the process in here, which is pretty straightforward. And we're going to say exactly what we want to do. We're going to match it here with the code. You can jump in here. I think if I start typing, let me go back up here. We're going to adding 2 n-dimensional arrays. We're actually going to just double it, which is use the same array. So we're going to double add an array to itself. So let's do that and write it into a GHOps component. There we go. We're going to write it. We're going to get a let's call this doubling Numpy array. Let's just call it double double array. That's fine. Yeah, we're not going to do this one. It's not really that useful. You're just doubling the numbers, and but it's baby steps as we move through this, and that's why I'm going to do it. Inputs can pop in there. We will make a wonderful list of arrays. Let's do 3 lists. 1, 2, 3. We're not going to go on to 4 yet. There's no comma at the end of that, so that's all I need. The outputs are going to produce an array. But the array of values will probably come out as an array, but I want to be able to see it as lists. So it is redundant to do this at the start, but because you cannot put from this wording here, array list to tree does not work in Grasshopper Canvas, and we have to use the entwine to bring these lists back together. So yes, it's kind of redundant. You ask yourself, why are you doing this to take it apart to put it back together? It's pretty basic operations. The point is we can do NumPy arithmetic and division and addition and multiplication and element-wise functions. We can analyze multi-dimensional arrays, and we can do it at lightning speed. So let's pull it out of there. We've got 3 lists. We are creating an n-dimensional array. We're going to print it. We're not going to use the list, and you will see that it's just multiplying by 2, and that's doubling it. But I don't want to do that. I want to do addition, so I'm going to add this, and it's exactly the same thing, but I just want to make a point of it. I want to add that array to itself. And that's it. That's all it's doing. It's taking the array, and you could output through another list to see your initial list, but I want to show you the speed of this. I think we're done. That's it. We'll try and do something a little more fancy, and I'll do 2 of these right now. So we're just going to do a save and run. Let's make sure this is working. So we're add doubling, which is like adding array to itself. Adding, I think I'm going to say that, adding an array to itself, because that's kind of what we did, and that's doubling an array. And we're just going to move that up like that. So we can eliminate this function, which we don't need. We've got our code, and we'll try and move through this a little quicker than how I've been doing in the past. If I run into any snakes, then I'll slow down and deal with them. But let's pop it in here. Let's do the NumPy double. It's certainly cleaning up the first set, and I just put I thought I put a / in there. Let's see if it runs. It did not because I screwed it up. Let's get rid of that one. Let's cancel that one. Yeah, I am making a mistake. Let's pull this one down. Let's grab our little IP address, post it, get that /, take that NumPy double call name and pop it in, and bam, that should work. And then because we flatten these lists, we're basically putting them in, but we're pulling out after processing them doubled, and that's it. Boom, boom, boom. And what have we done differently? We have number. The arrays are coming in at pretty soft, smooth numbers, but you can see they've doubled from 0.6 to there. And that's all I wanted to do, and I'm not going to overthink it. So I'm going to grab that name again, copy it. I'm going to right click here. I'm going to name it, bypass the icon, and I'm going to go up here and say, if you want to make this function, you've got your call on it. And that is it. Now let's do something a little different. Okay, so yada, yada, yada. Let's do it again and see what we can do. So I'm not a very intelligent person. I just function incredibly well by doing the same thing multiple times. Repetition is the key to success, or at least to succession, maybe not success in any other way. So what we're going to do now is we're going to add 2 different arrays. So here's what we're going to do. We're going to add 2 different arrays together, and it kind of knows what we want to do. We want to write that into a GH component. We're going to do that. And we'll just tab and enter through here. So you can definitely do this stuff on your own. Once you train a kind of one of these apps to write itself, an array will come in. I just want to double check. I'm still making the mistake of using list and for loops for this first section. I'm happy to correct these. List inputs. I think I want to do this. I want to list out 6. Now, why do I want to do this? Because I have 2 different arrays, so I want to see both of them, I think. Let me just see what I had in plan. I had ones that would output all 6 arrays. I think it was just coming out as array as a list. It's adding them together, so I don't really need 3 unless I want to see everything. What was I outputting? I was just outputting a list, which is very interesting, but I wanted to input Why did I want to do that? Two different arrays being built by six. Okay, so two different 3D arrays are going to be added together. So that's why I have gone in here and typed in array list 1, 2, 3, but I am actually going to take it farther to 4, 5, and 6. And that should be the end of that. So that will give us two nice 3x3 or 3 by whatever lists. We're going to change this up and do rows and columns later on. I'm going to output a list. To read it, it should be 3, and that should be all I need. So I'm going to add 2 together. And you're going to find this starts to come in handy when we do element-wise calculations and very fast things with, and that's what it's choosing to do right here, nice and easy. It is giving me one array, second array. It's got the types. It's telling me what they are. I don't need all this extra information down here, but since it's just going to print, may as well see what's happening. I think the one thing you have to do is when you go in here and go into preferences, you want to make sure that you are not hiding your Rhino Compute console. I cannot believe I haven't said that till the 8th video, but do not hide your Rhino Compute console or you will not see it here to debug and see what's going on, but definitely have a terminal so you can witness what's happening. And I wonder if I have any memory cached already. And I have to wonder in the past example, if I actually, if I had taken my cache off. I don't think it did, but you want to do that. Otherwise you're not going to see your updates in your terminal window. We're okay. We're going to erase this one. We're going to continue along with this. Sometimes I go back and I get the colon in there, tab through it, and then the next line will auto write itself. Yada, yada, yada. It's the exact same thing, but you see the change from add one array to one array. It's adding 1 to 2. It should understand those operations perfectly, and you can predict this working without too much problems, except you're going to have a lot of inputs. But anybody who's making their own plugins, in my opinion, people overdo their components. Their components just do too much or are too specific to some outcome. Not all the time, but sometimes that's what happens. And really, I'm just breaking it down to the simplest numerical functions that I want to be able to call and use Numpy while working Grasshopper from the very outset. And to me, that's numerical control, computer numerical control, driving my own creative impulses. Oh, that sounded pretty sweet. You can quote me on that one. So let's pop this one in here. Let's go down and grab the name of adding, add. We did double, this one's add, so that makes sense. We're just adding 2 arrays. I would make sure we didn't have the same names. It won't matter. Hey, I put that little hashtag in there. I think I made the same mistake again. I did. What did I do? Where am I putting that? I'm going to have to watch my video again to see where I'm doing that. Grab this one, copy, double click, paste, / numpy add. You can type it in, but I enjoy cut and paste. And that's it. We're going to need a couple of bits of data. We're going to need this one, and there's no scaling factor, but there's no problem grabbing this data again and having 3x3 arrays in different lists. I think this is a little overdone, but what did I do last time? I think we can handle it. I think it's like a big monstrous thing. Let's do a little randomization. I think this is going to build some cool geometries. When I start messing with a building with the other array to mess with the building that's driving it, I think this is going to be pretty fun. And this is where Wickerson kind of lets loose on creativity, and people are like, why is a visual artist for 30 years? Give me at least credit as a dropout mathematician from the University of Waterloo with a slight teachable. It just took me 30 years to want to teach this stuff. We'll have that array going in here. We'll have that array going in here and an array going in there. And you'll see that you're actually adding these arrays together. And you can double check your math. You can double check it over here, but you can also double check it over here. So I'm just going to quickly grab that. We're going to call this one numpy add. We're going to right click and we're going to give it that name. And I'm pretty happy that everything's functioning and you're learning how to make functions for yourself, which I think are a very powerful tool. I've always wanted to go as far upstream as I can, and the only thing I haven't done yet is getting into the little breakdowns of what's happening in Python and Numpy when it's actually doing calls on its methods, and I'm not getting into writing those methods, but I certainly want to use them. So if you've spent any time with GHPython or in C# trying to do things in these components in the Math tab, and you've gotten as far into it like script parasite and calling things, going back and forth, I just don't think there's coming back out of the libraries of Python if you want to tap into them. This is going to be endless as we begin the series. It's going to start with Numpy. It's going to go really hard through geometries, and then bang, it's going to hit pandas. We're going to be reading complex files, and then we're going to slip into more complex Python 3.0 libraries, learning the entire process while building apps. And hopefully I'll be, a genius by that time. Who knows? That's enough to run that. I'm pretty happy. I do have to make the habit of saving once in a while. We are nearly done. What I do want to do is I want to spend a little sample of what we passed up here. You'll remember I wrote a couple of notes up here on shape and data type. So I just want to generate 2 scripts from series 3x3 arrays, and I want to show you how you can read out the data types and the shapes, and they might get into trouble with tuples and strings in that manner. So I think you'll find the next video very interesting. I'm also going to produce a really cool, while this is in the waiting, I'm going to produce a really cool data visualization out of this data, and probably take new models. I'm not going to use those models I had before, but think about it. You have one model being driven here, but you can add these numbers to this randomly while keeping the basic structure. Think of your building as this structure. And if you understand Rhino as curves building surfaces, you know that those curves come from points, those points come from numbers, and you're driving those numbers right now with Numpy arrays. And this is an incredibly powerful tool. I think anybody interested in computational design and certainly learning programming, and you're a visual person, this is the way to go about it. So stay tuned for my videos. I will hit pause now. Let me take a look. I'm going to stop recording, and then I'm going to load this up. Thanks for watching.